Okay, so how about cubic graphs? Again, we're expecting some elongated S shapes. And the powerful thing is the domain's anything. So we don't have to worry about what we're plugging in, like the square root graph, where we have to worry about a red flag. I can just start plugging things in. And so we just have to be careful about what to plug in. So let's just plug in some values that make some nice cubics. So x plus 1, how about we throw in a negative 9, right? Because the cube root of negative 9 plus 1 would be the cube root of negative 8, which we know to be negative 2. So there's a really nice value. Plugging in some other nice values, how about we throw in negative 2? This becomes the cube root of negative 2 plus 1, which is the cube root of negative 1, which is negative 1. Right? 0 is going to be a nice value because the cube root of 0 plus 1 is the cube root of 1, which is just 1. And if we throw in a 2, actually not a 2, let's see, 2, 1, next value, we want a 1, we got that. How about an 8? How about a 7? So if I throw in a 7, cube root of 7 plus 1 would be the cube root of 8, which is 2. And that's a 7 right there. So I got lots of data points. So let's go plot this and get a feel for what it looks like. One of my values, 1, 2, 3, 4, 5, 6, 7, 8, 9, and negative 2, somewhere like right off my board there. We got negative 2 and negative 1, right? We've got 0 and 1, right? And we've got 7, 1, 2, 3, 4, 5, 6, 7, and 2. So you can start seeing that S shape right there. And again, the arrow is indicating that this goes on forever. So there's a classic cubic shaped graph, and that would be what the graph of the cube root of x plus 1 looks like. Okay, so the next one, a little bit more going on, but again, this plus 3, we first have to figure out what that is first before we do that. Cube roots have a nice domain, so I don't have to worry too much about what goes inside them. Just plug in some nice neat values. So, again, we know negative 8's a nice value, so how about we throw in a negative 6? So that gives us the cube root of negative 6 minus 2 plus 3. This is the cube root of negative 8 plus 3, which is negative 2 plus 3. We get a value of 1. Okay, another nice value is negative 1. So it looks like if you let x equal to positive 1, right? So the cube root of 1 minus 2 plus 3, that becomes the cube root of negative 1 plus 3. Cube root of negative 1 is negative 1. We get a 2 out of that. A 0 also is nice. I missed it over here. But if we let x equal to 2, this is the cube root of 2 minus 2 plus 3. This is the cube root of 0. 0 plus 3 would give us 3. Okay, 1 is also a nice one. So what makes this 1 would probably be 3. So the cube root of 3 minus 2 plus 3, that's the cube root of 1 plus 3, which is 1 plus 3, giving us 4. And last but not least, getting us an 8, I would have to go out to 10. So the cube root of 10 minus 2 plus 3, that becomes the cube root of 8 plus 3. 2 plus 3 is 5. So we got a lot of data points there. And again, notice what I was trying to do is I know what my nice cubes are, right? Negative 8, negative 1, 0, 1, 2, 8, 27 would be in there, but that's just too big. So I'm just trying to find values of x that create those nice, neat cube roots. So graphing my data, we got negative 6 and negative 1, or positive 1, I'm sorry about that. We've got 1 and 2. We've got 2 and 3. We've got 3 and 4. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 5. 1, 2, 3, 4, 5. So again, you can start seeing with those graphs, you start seeing that nice looking classic S shape, classic cube root shape. And so here would be our graph of that function. Nice strong function in terms of domain and range. So that's how you graph cubics. All right, and that should wrap up 10.1. Pretty long section, lots of details, a lot of nuances, and just keep working at it, because I promise you we're going to keep seeing all this stuff over and over and over again. So let's just keep moving forward.